Good afternoon, everybody. I hope you had a great lunch, and now that your bellies are full, you must be slowly falling into sleep. But not here at Joy of Coding, because we now have the most exciting program for you, which will guarantee keep you awake, because it's time for our lightning talks. A lightning talk takes exactly 5 minutes, and during that time you will have a wonderful introduction into some principle or technology or anything really. And when those 5 minutes are up, we'll give the speaker a great applause, whether they are finished or not. So we have a great lineup for you, 8 speakers in all. So we have only 50 minutes, so I will be very brief in my introductions. And the first speaker is an organizational anarchist, an avid cyclist, but also a code review specialist. So give us a hand for Elisabeth Zagroba.
Hello. I disagree with the earlier introduction. Feel free to take a nap. Let's see. Okay. Brilliant, my slides. I'm here to tell you about how to strengthen your code review skills. My main message will be to say less than you were going to. Let's see what we're going to talk about. Okay, so I've got this feedback funnel. This is all of the feedback that you could possibly give in a code review, and as I go through the talk, we'll whittle this down to fewer and fewer things in the funnel until you have just like the little bit of stuff you should actually say in a code review instead of all the stuff you were going to say. Okay. So let's say you get a request, you're working in feature branches, you get a merge request, someone asks you to review it. The first thing you should think about is, who are they to me? Who is this person? What relationship do I have with them? Are they going to be able to listen to the feedback that I have? Are they on some other team? What's their roadmap like? What are their constraints on their time and abilities, right? If they are in a place where they're really stressed out and don't have time to listen to the feedback that you would give them, just don't give them any. You don't have to. Great. So now we're like out of the blue zone. We're into the more teal part, right? We have less and less feedback we're going to give them. Okay. So the next thing we're going to do is focus on what matters. Start by praising what they did well. That will keep them so they keep doing that good stuff, and that stuff stays in the code base. When you're reviewing the code, ask, what does the code do? A lot of the other stuff that the code doesn't do or just doesn't matter, you can decide to let go of. As a tester, I'm often looking at the code, reviewing it for readability, looking for reusability. What pieces do we want to take out of this, like one particular test and move into a more central place? Or what are some weird scenarios that could happen? What error cases should we handle here? What are we missing? I ask for some what ifs. But if you're getting a merge request like this and you're asking, oh, why is line 62 and line 65 only one line of white space and then the other two are 2 lines? Just no, that is not the kind of detail that you want in a merge review. Let the linter catch that, have some coding guidelines, have something to point to so that you're not offering that feedback over and over again, right? If it's something that's just named not exactly the way you would name it, it's fine, it still works, it still does the thing it's supposed to. Let it go. Okay. Then, once you decide, we're like down to just the lighter green feedback now. So we have to communicate what we want to communicate well. We have to decide what level of abstraction we're going to offer it at and in what format. So you probably, like GitLab and GitHub for that matter, default to offering inline comment suggestions, right? Of like, you missed this, you missed this, you missed this. And you don't want to communicate that if they missed it 20 times. Take a step back, communicate it on the entire merge request, or even better, move the conversation to Slack, move it to a Zoom call, decide how this person will receive the feedback, what is the best way to send it to them, and then you have the opportunity to say, let's discuss it offline, do something different. The default in the tool doesn't have to be your default. Yeah, that's all I got there. Okay, so now we're down into yellow, feedback you're actually gonna get right. We got less, even less. Okay, so now we're going to shorten the delivery gap. That means the time between when the person wrote the code and the time that they are receiving this feedback that you have about their code. Make that smaller. So if you can make that, like probably if you're doing feature branching and merge requests, you're doing that really asynchronously, the closer you can get to doing it at the same time, right? Why have I had all these slides separately where I'm showing the examples? Just put it all together, do it all at the same time, pair together, and then instead of having a situation where you're waiting for hours or days to get the feedback, you have to switch context, you don't know what's happening anymore, you can stay in the same context and work together. It doesn't have to be a competition where you're criticizing each other. You can collaborate and foster a good relationship at work. Doesn't that sound nice? Just do that. Yes. Here are other things about feedback and code reviews. Look at them later. That's all. Thanks.
Amazing. Well, that was absolutely amazing. Much information in one short 5 minutes, not even 5 minutes. So I just might have to change my code review style. Thank you, Elizabeth. Next up. Being both a software engineer and a musician is a particularly effective way of getting on stage this year. Our next speaker discovered this too. Please let your hands come together for Antonello.
Okay. Hi everyone. So come together, the joys of the community. Let's talk a bit about one of the most important tools that we have in every industry, actually, the community. We are being part of a community right here, right now. I'm Antonello. I'm a software engineer at Molly in Amsterdam, but I'm also a musician. Are there any musicians in the room today? I guess so, right? Quite a bit. Yeah, expected more actually, but yeah. Yeah, again, I'm also a musician. Back in Italy, I started a band, I started writing songs, we produced a record, we produced a music video, a theater show even, so we toured in the central Italy for quite a while, for 3 years. So I've been an active part of the musicians community, but I've been also part of the coders of the developers community. I've been part of my PHP user group in Rome. I spoke to a couple of conferences in Verona. Then 3 years ago, I moved to the Netherlands. I started attending the O10 PHP local meetup. So I try to be also an active part of the developers community in both the countries. And I started building in my mind a comparison between these two communities, what we can learn from each other, right? Especially on their artifacts, on their events, on their practices. For example, I started making a comparison between jam sessions and pair programming. They're kind of the same thing. There's brains working together towards a single objective in a way, but pair programming is more structured, there's more guidelines. Jam sessions are more free flow, more creativity, improvisation, which is incredibly beautiful. But they're both healthy practices, right? So as much as open mics and meetups, both are very good for networking, are very good for learning new things and new music, for experimenting new things if you're a speaker or a songwriter, for example. Again, both very, very healthy practices. That's where the problem starts, because our daily job as a software engineers compared to live concert is it's different. As software engineers, we are very well paid. It's relatively easy to find a new job when we lose one or we decide to change jobs compared to other industries, right? It's not the same for a musician that plays their songs live. It's hard to get consistently new gigs and to be paid fairly. It's still hard. So this leads to competition, and we don't want that. It's not healthy. Festival and conferences, yeah, they're both good. Again, good for networking, good for learning new things, good for experimenting also new things. But what I experienced in festival, especially if you're not an established musician, if you're not a famous musician, is competition again, because I want to play in that time slot where a lot of people are, and I don't want to play at the 2 p.m. time slot in which nobody's listening to me, or I want a bigger name in the festival poster, so that kind of competition, again, unhealthy. So what did I learn in the end? That it's, in both cases, a team sport. So you can write songs solo, you can write code alone, but in the end, the beautiful pieces of code and music are written together, are created together. So collaboration. What we can import from the musicians community is maybe the free flow, the creativity, the improvisation, room for improvisation, right? What we shouldn't learn, we shouldn't import is competition. We don't need competition between engineers, between conferences, between tools. We don't need competition. We are stronger together. Again, it's a team sport. Thank you.
Well, those are definitely interesting similarities. Thank you, Antonello. Next up, a Frisian abroad, a model-driven geek, and a code sculptor who loves language engineering, which is actually what this talk is about. Give some hands for Meinte Boersma.
So, the joy of language engineering. Then, what is language engineering? Here's a definition for a language, which we have to start with. A software language is something I see as a set of tools to support some kind of digital activity. Tools, you can think of an IDE, or an editor, or a compiler, or an interpreter, or a linter, or what have you not. So here's a bunch of languages software languages that you might know. I'll drop the software from now on because it's sort of implied in this context. So first of all, we have all the nice programming languages that we know of. We also have modeling languages like UML that some of us might still know. My main interest is in domain-specific languages, or DSLs. So we have a lot of technical DSLs like HTML, CSS, SQL, etc. I'm not so interested in those. I usually try to deal with, as much as possible, with business-oriented DSLs. So DSLs for business users, non-programmers. Okay, you might have heard of location, location, location. We have the same thing in language engineering. Notation, notation, notation. Notation of a language is the primary aspect or the key aspect of a language and also of DSLs. It's after all the main user interface, so to speak, of a language. You might recognize a couple of these languages here. Don't think I give bonus points for if you can name them all. By the way, we language engineers also refer to notation as the concrete syntax of a language. So most of those languages that we see, I won't go back. Most of the languages that we see here and also here are textual. That is, the stuff you write is purely text in a text editor or something like that. So how would you go about making such a textual language? Well, you need a parser. You need a parser that turns your text from text into structured data. And that structured data we call an abstract syntax tree. That's also why we have concrete syntax, because you have concrete syntax and then also abstract syntax. So this abstract syntax tree, or AST, is a sort of a tree. It has nodes, it has data on the nodes, and it has relations between those nodes. So your text gets turned into that as soon as you parse it. As soon as you have an AST, you can do interesting things with it, like compile it, run it in an interpreter, check some constraints, do syntax highlighting, and do things like content assist. A lot of these things you have to feed back into your text editor to provide the user with enough feedback. And that's not always so joyful. This is a bit complicated. It's well understood, but it's still tedious. So it's a little bit like there's the upside down thing going on, where you have your prose in nice concrete syntax, and you have a abstract syntax tree that lives sort of in down under, together with, I think, as will. So is there a better way, or a nicer way? I think there is, and it's called projectional languages. So this is how you make a projection language, and you do that by turning the AST into the pro. So not a text, but you start with an AST, then you have a projector which projects your AST into a nice projection. And then this is typically rendered as a DOM by a browser. So this works very well. It has a lot of advantages. Yeah, let's go. I'm missing some slides. So yeah, so why is this nicer, or at least why do I think it's nicer? Your notation can be anything. It can be text if you prefer that way, but you can also make it completely graphical or something in between. The key thing is you have to make this projection editable. So you expand the projection. So you expand the projector or the projection with actions that the browser can trigger, and then you feed those actions back to the AST to change it, and then you run the projector again, and then this whole cycle starts anew. Yeah, I'm missing a slide or two, it turns out. So if you have any questions, then come to me afterwards. I'm also writing a book about this stuff, so I have QR codes, etc. for that. And if you have a really good question, the first 3 good questions will get a code for a free copy of the book. Okay, thank you very much.
Thank you, Meinte. My guess is there will be much more upcoming about abstract syntax trees. Our next speaker is a shape-shifting test engineer. I do wonder what he will change into. A unicorn or a griffin? Let's find out with Arjan Blok.
Hey everybody, I'm here to talk about the Test Automation University. Now I must warn you, it's not a very educational talk, but it's more a story about my joy of coding. But if there's one thing you can take away from this, is that if you even are remotely interested in testing and test automation, you should definitely go check them out. It's a website where you can do free trainings, and with the answering or doing these courses, you can earn points, and with these points you get a ranking. So you start basically as a unicorn, and you can go all the way up to a griffin if you complete all the courses and earn a lot of points. The reason I'm on stage here, or I submitted this lightning talk, was in the last Joy of Coding. That was in 2019, unfortunately. I met Angie Jones. She is very well known in the testing community and also a great speaker. She was on stage here giving a talk, and I thought it would be cool to be on the same stage talking about, because she's actually also one of the people behind the Test Automation University. So I thought it would be cool to be on stage talking about a product she launched, basically, sort of an homage. So when the Test Automation University was initially launched, you could do a lot of online courses. And it became sort of a hobby of mine of doing all of them, and then when a new one came out, I would also do it. They would also have a profile page where you could see your profile, your points, the current rank you have, also the certificates that you got for every course. But then they released a new feature, which was a leaderboard. And lo and behold, I was at the #1 spot. Well, shared actually, but my name beats the other guy alphabetically, so I won. So, you know, getting to the first spot is what they say is easy, or getting to the top, but staying there is difficult. So the race to be on top, because I made a few mistakes answering questions, you know, I didn't know everything. So staying on top was the goal here. You know, it's unlike Donkey Kong. So with everything, all the courses that I took, I learned a lot about API testing and about JavaScript, TypeScript. So I was able to hack together a script that basically scraped the website for all the course information and brute forced all the answers, stored that information. Then all I needed to do was write another script that submitted that information. Yeah, I was golden. I had some challenges. No time for those now. But I managed to get the first spot with a perfect score, so I was pretty happy about that. And I tweeted, so I made a tweet about that. And unfortunately, well, I made it very obvious I cheated because Rick Ashley was there. My account got suspended. So I talked to Angie Jones, and she told me that they thought I hacked the database because I had all that information. I explained her how it worked or what I did, and I promised to never do it again, of course, because cheating is bad, even if the website that you do it on teaches you everything you need to know to do it. Yeah, and another. I think I missed one slide. Well, anyway. These lists, don't take them too serious, because if I can do it, well, the current guy that's at number 1 also has a perfect score, so we all know what's going on there. Thank you.
Well, I think Arjan turned out to be a hacker, and well done from him. Our next speaker is a software consultant by day and a tinkerer by night. Let's see if he can have a macro impact with his presentation on the microbit. Give a hand to Ties van de Ven.
Hey everybody, welcome to my talk about having macro impact with a microbit. First, a little bit about myself. My name is Ties van de Ven, and I work for a company called J-Driven. And a big pillar of J-Driven is sharing knowledge. That's why I'm, for example, on this conference. So we go to conferences, we give trainings, we do coaching. We think it's very important to increase the level of engineering everywhere. And because we like sharing knowledge so much, at some point we came in contact with a foundation called the Yink Foundation. And they asked us, hey, we're trying to put children who don't have that much opportunities in opportunity-rich environments. Can you help us with that? Because IT is a very opportunity-rich environment. And we were instantly like, sure, let's do that. And then it dawned upon us that, oh shit, we need to entertain some kids for like 4 hours. How the hell do we do that? And hopefully teach them a bit about programming as well. So when you look on the internet for that, one of the first things you come across is the Scratch programming language, which is an amazing visual language where you have building blocks, and you can use those building blocks to create code to animate that little figure over there. And these building blocks are very good for kids to learn how to write software, because those building blocks will only fit into other blocks if the notches and such are correct. So you have a lot of visual clues for kids to learn what goes where, because otherwise it just won't fit. And as you can see, they can be very easy instructions, like when the flag has been clicked, forever, move 10 steps and turn around. But this, I had some experience with showing me this kids, and it's not really good to keep them engaged for a longer time. For that, it really helps to add some hardware to it. Lego Mindstorms is something I worked with kids as well, which is really cool. You have Lego robots, and you can use a Scratch-like language to program them. And there's whole lots of chaos going on with robots fighting each other and such. A lot of fun. The problem, however, is when the kids like it, then the parents come to us and ask, so, how much does it cost? What can I do to get this for my kid? And when they hear the price tag, then it suddenly doesn't become an option anymore. So we kept on looking, and we ended up with the microbit. And microbit is from originally made by the BBC, and now by the Microbit Educational Foundation. And its goal is to inspire every child to have the best digital future. And just like Lego Mindstorms, it combines Scratch with hardware. But the nice thing about this, it's priced at 15 euros. So it's a very affordable thing. So what do you get for 15 euros? You get an LED display with 25 LEDs of LEDs, so you can put text on it, you can put numbers on it. You have 2 programmable buttons. You have some ports where you can add more hardware to it. There's a whole bunch of sensors, like there's Bluetooth, it has a light sensor, it has a compass, it has an accelerometer. So a lot of sensors you can play with. And the code kind of looks like this. where I wrote a bit of software that on start, we turn off the LEDs. I don't know if it's readable actually, but it says on shake, send the number 1 over Bluetooth and turn off the LEDs. And when the software receives a number, then turn on the LEDs. And then you get into a thing where, for example, you have 2 of these, and they now, over Bluetooth, you can throw a ball. That's all it takes for 2 pieces of hardware to communicate over Bluetooth. When I saw this, that's when I knew that the microbit was something very powerful indeed. And you can do other cool projects with it. I only picked 2 because we have 5 minutes. This used to be a GIF for a moving image, where somebody mounted a microbit to a steering wheel so it could use it to actually steer a motorcycle in a game. Some guy automated his entire plants to water his plants, where a microbit would control that servo engine to drip water in the plants now and then. And he even had 1 microbit in the center which connected to Bluetooth to all those things to give them instructions and such. So it's actually a really powerful, cool thing. And for education purposes, it's even more brilliant because there's a very active community in this. And because it's for education and for kids, basically all the material is for free. So if you want to get started, those things are only 15 euros. If you don't know what to do, just go on the internet and you get tons of course material for free. If you want a link for that, just go to microbit.org. If you want to have these slides or have any questions whatsoever, feel free to add me on Twitter and we'll do love to help you out. Thank you so much for your attention. And enjoy the conference.
That was impeccable timing. Exactly 5 minutes. I'm impressed. And also, the microbit is yet another gadget I must own. No, not more. Anyway, he's a coder, a runner, and a tense gritty worshipper. He will take us from the virtual to the real. Please welcome Gerald de Jong.
Thank you. How do we go to the next slide like this? Yeah. Okay. So I have been a coder since I was a teenager. And for about 20 years, I was freelancer in the Netherlands, which gave me some time occasionally between gigs to explore some fun stuff. So I went back to something that I had picked up a long time ago from this guy. Back at university, I happened upon a book by Buckminster Fuller, and I was completely fascinated by all the stuff that he was talking about. So it took me a while to get my head around it, and yeah, life went on, so I just didn't pursue it all that much further. Later on, another person appeared related to Buckminster Fuller, and that's Kenneth Snelson. He's an artist, and he makes this kind of art. Probably a lot of you have seen something like that in Holland, because there is at least one of those in Holland. So Ken was like my hero. I'm not worthy, because I was always fascinated by this kind of structure. These structures are special because they only consist of pushing and pulling elements. There's no twisting and there's no shear and nothing else. It's all just pushes and pulls. And the pushing things, the bars, are not touching each other. So it has a very interesting structure. Always been fascinating to me, and since I was a coder, I made a software model early on, and I started playing around with it, and I found out that you can explore a lot more when you don't have to worry about reality, when you can instead just deal with the software model. And basically that's the biggest difference between Kenneth Snelson and me. I went to visit him in Manhattan one time. Sort of kind of like I had to go see this guy because he created these amazing things. And so the difference between him and me is that I grew up coding. So I know the joy of coding from my teenage years, and he was from a previous generation, so he never did anything with coding. So recently, I decided to stop with my freelance activities and build a site and explore what I could in terms of this technology, but then also to build it physically, because I had been spending years building it virtually. And when anybody asked me, so like, what's your hobby? And I could just show them a screen. And I thought, maybe someday I can actually build it for real. So I ended up recently building these things for real. If you point your phone at this QR code, you can see the software that I built to design these things. And this is a battle that I've been having since, hate to say it, from the 90s even. I was playing around with this kind of structure, but I could never put it online. And then came Java and the applet. So I could put applets online. So I built stuff, but a couple of years later, it all disappeared. Fortunately, in the past few years, the technology to do this has reappeared. I do it with 3JS, and I do it with Rust, and the physics engine is written in WebAssembly, which is amazing technology. It's what applets kind of were meant to be, in my opinion, because you can create a super fast functional module and treat it like a piece of JavaScript. So when you're running this program, you will see the WebAssembly running in your phone. So yeah, the idea here was what can I build with this stuff? And what the original artist, Ken Snelson, was able to build was tabletop models, and then he would sell the idea, and then he would build a big one. I start with a computer model, so I was thinking, can I actually ever build these things? And it took me a while to figure out the techniques, but eventually I could build it. And as a result, I could explore a vast design space that basically nobody has ever had access to before. So I couldn't stop, and I still can't stop. So here's an example of something that sort of looks like a person. So this is what I do, and I'm going to continue exploring and seeing what we can do further. The next project will be a 3-meter tall example of this with glass bars with LEDs in them, so it's getting a little more exciting as time goes on. And I have a little online store where I sell sort of, like, the idea is to get this into people's hands, to get people conscious of how this works and to get a feel for it in your hands. So if you go to that store, you can order with a discount code, Joy of Coding, 20% off. And I've got a few with me, so if you order now, I can give it to you before you leave. That's all. Thank you.
Oh, here. I found it. All right. Wonderful gravity-defying contraptions. He is a teacher of all things front-end, freelance front-end developer, but apparently also the author of our most joyful fantasy processor emulator. Please give a hand to Maarten Hus.
So 6 months ago, I needed a little bit joy of coding. I was between projects. And of course, like so many of you, I decided to create a fantasy CPU emulator. Why did I do this? When I started to learn how to program, it was in Java, PHP, JavaScript, all high-level languages, and was far, far removed from the CPU. And after 3 years, I was thinking, I'm programming all these things, websites, forums, you name it, but I don't have any clue what the CPU is actually doing with my programs. So I came across this video on YouTube by a guy called Richard Buckland, and what he did was he showed a very simple model on how you can learn to understand what a CPU does. So this is an interactive demo, and I'm going to explain to you what this program does. So first, the CPU communicates with the memory, with the RAM memory. So those are the cells you see below, starting with 9, 14, and 10. And each cell in memory has an address, and that address is it's just in the memory. They start at 0 and they continue all the way up to 15, because in this fantasy emulator we don't have that many bytes. The upper part are the registries, and a CPU has registers. And a modern CPU has a lot of registers, but this one is very pitiful. It only has 2 working registers and 2 bookkeeping registers. So the first registry is the IP registry, and it contains where the program is currently running at. So you can see it as a sort of, it keeps track of the line. And the IS register keeps track of what instruction is currently executed. A CPU, and to my amazement, only works with numbers. So that was one thing I learned. And everything is a number for CPU. An instruction is a number. What do I have to do? And of course, calculating with numbers, those are also numbers. So code is data and data is code. So the CPU has a limited set of instructions. Each CPU manufacturer defines their own instructions. For example, the first instruction is 0, means stop the program, I'm finished. And for example, the most fun instruction is 7, that makes a beeping noise. It's not the code clavier, but it's fun. From 7 to below, those are 2-byte instructions. Those are instructions that don't operate on a single memory cell, but on 2 memory cells. So now that you understand the basics, let's see what this program does. So the first thing you have to understand is when you program in such a manner is that you put your variables away from your code. So that's what you see below. You see 5 and 37, so very far away removed from the code. We're going to load in those 2 numbers and count them up together. So first step, what happens is that the instruction pointer is loaded with 9, because that's on the first cell because of the IP. And then it will look to the next cell, which is 14, and will use that as a reference to see what you want to load in memory. In this case, the 5. That's why it's orange. So the next step will land us on cell number 2, because 9 is a 2-byte instruction, so it skips 2. 9 of 10 loads up into R1, so we will take cell number 15, load it up, put it in the registry, and then it will continue to the 4th memory cell. This is a 1-byte instruction, 1, and what it does is it increments R1 plus R0. What's funny about this is that a CPU can only operate on registers, not in memory, so it has to do every calculation inside of a register. So if I skip this step, you'll see that the answer is 42. But that 42 is now locked into a register. We need to see it, because otherwise we can't know what we calculated. So what 11 does is it's going to write to a certain place in memory, and in this case it's going to write at position number 8, which points to that 0, which is now yellow. So it's going to write it down there. It's going to say 42. The next instruction is print. This is a special 2-byte instruction. It actually looks at the next cell and literally prints that one. So and now you can see in the printer below, it printed 42. And also, it hits 0 and it will stop. The funny thing about this way of looking at CPU is that you can see that code is data and data is code. So the 8 on cell number 6 means something different than the 8 on cell number 7. So it has a different meaning. So this is a very, very small program which counts up 2 numbers, not too fancy. But I have a very, very, very big program here. And what it does is it fills a hole in my instruction set. I don't have multiples. I can't multiply. So what I'm going to do is I'm going to put this up to speed number 1. Just run it. It will... no, I don't mean speed number 1. I mean even faster. Play it. Yes. And what it did is it calculated the 5 times 4. So this code you see here, it took me about 2 days to write. I'm not used to writing code like this, so I really had to get a pen and paper, and then I had to do that. So if you want to see more, just go to my blog post. You can see all the examples, and I also have a part 2 in which you can see how it's made with React and JavaScript. Thank you.
Ah, the joys of self-modifying code. It makes me feel nostalgic. Back in the days when you had a Commodore 64, I don't know how many of you had a Commodore 64? Good. You can write these lovely programs in assembler and then just code a for loop by incrementing the actual comparison value so that you didn't have to use a separate memory location to store the counter. The only disadvantage was that if you stopped the program halfway, then all your counters were initialized with the wrong value. So really, self-modifying code, not such a good idea. But I see that our next speaker is ready, and that is great, because he has a passion for gamification and motivation theory. Not surprisingly, this is exactly what this talk is about. May I have a hand for Alexander? Too complicated.
I was the only one that his last name wasn't called, okay. Hello, let's just immediately get started. My name is Alexander Gatzacharias, that is me, and that is my avatar, splitting image. I work at JDriven, this talk said everything about it, and I'm going to talk about 5 gamification examples that could make your projects more fun. I am noticing that the laptop doesn't necessarily like the big screen, so frame rates might be a little bit lower than expected. But you know, when you challenge Murphy's Law by making a game for a presentation, you know. Okay, so we're going to talk about things to make your projects more fun. And number 1 is fast feedback loops. If you work in agile environments, you might have heard this one before. It's all about bringing feedback back as fast as possible so that you can react to it. Well, games do that a lot of times. Oh, yeah, nice. For example, in the ways of leaderboards, as has been told before. And leaderboards is a very good way to quickly show feedback to players that, you know, they are doing better, that they are growing. And in your projects, you could do something similar. For example, most lines of code written leaderboard. Or maybe something better than that, most lines of code, refactor leaderboard, and then you can be number 1, and it gives a good feeling, and that is what makes fun. And then we have peer motivation, or as you might have known, peer pressure, but this is not about pressuring for doing things, people doing things that they don't want. It's about, you know, creating an environment of inclusion where people feel a part of a team and, you know, follow the best practices within the team. So I'm trying to find an imposter. Everybody's telling me number 4. Number 4 is saying it's not that it's not them. Well, I'll just take a guess, and thankfully, that is the imposter, and that's all about, you know, if your whole team is writing code, test-driven development, then there's very slim chances that there's somebody in your team that is not going to be doing test-driven development. Well, then competition. I just heard competition, you shouldn't do that. I'm telling you, you should do competition. So that's a nice contradiction. But it's about friendly competition. You know it in sports, football, esports, and you know it in cybersecurity with red versus blue teams. You probably heard about that one before. And I mean, you could do something similar with your projects where, there we go, where you have one team trying to break the project of another team. See who can break a project better than the other. There we go. As you can see, I'm a little bit of a pro gamer. Then we have progression, very important. People hate having the feeling that they are stagnating, that they're not going forward. And progression, and games know this, and they show progression very visually with progress bar, levels, you name it. Progression is very important. Badges, for example, you saw an example, just a couple talks before mine. And it's something you could actually do in your projects as well. Make it very visual what somebody needs to do to become a tech lead and make a progress bar towards tech lead or something like that. And, you know, give people the sense that they are getting closer to becoming a tech lead. And once they are a tech lead of a project, maybe the architect of the project, and, you know, then they have that good dopamine hit that they're, you know, growing. And eventually, you know, they're going to become, well, in games, you're going to call them gods amongst men. But in maybe what we call it in software engineering is the single points of failure, pretty much. And then the last one, and personally I think it's the most important one or the trickiest one to implement, but very important one is challenge flow. All right, so let's go surfing. So challenge flow in games is all about creating the perfect difficulty for your players. Things shouldn't be too hard or too easy. If things are too hard, you get frustrated. You're like, what the hell is this? How am I supposed to do this? Ever heard of deadlines, unreachable deadlines? It's exactly that. People get frustrated. If things are too easy, people get bored again. It's like, okay, this is easy. I'm not being challenged. I can do this with my eyes closed. Damn. And then that is the moment where people, start searching for other, projects. So what you want to do is create like the perfect difficulty where people get challenged, where it's fun, where they think that they are growing, where they're, learning new things all the time. Sometimes fail, sometimes need help, things like that. And that's the perfect difficulty curve that's gonna keep people engaged and add a lot of fun to the project. As you can see, time goes positive, so I have infinite time, so that's good. So thank you very much. This is my Twitter handle. Feel free to hit me up.
That was absolutely amazing. Best visuals ever in a 5-minute presentation. Thank you, Alexander. It was magnificent. Which also leads to the conclusion of this most exciting part of the program of Joy of Coding. So I would like to thank all the lightning talk speakers for this magnificent part of the program. And I would like to ask your patience for a brief moment for a technical intermezzo while we prepare for our next speaker. Thank you.